Friends, welcome to my YouTube channel. Today we'll be looking into hypergeometric function or hypergeometric series. Yeah, hypergeometric series. Now, now before the hypergeometric series, you must know the Pochhammer symbol. Now here's the Pochhammer symbol. Pochhammer symbol. Let me use a red pen for that. A Pochhammer symbol. So if you have a subscript of n, so a subscript of n is equal to gamma of a plus n over gamma of a. So that is Pochhammer symbol. Yeah, take note of that. Okay, now let me look into the hypergeometric series. Now, if you have something in this form, you have sum of n running from 0 to infinity of a1n, a2n, a3n, dot dot dot, ak n multiplied by z raised to the power of n over b1n, b2n, b3n, dot dot dot, b I n multiplied by n factorial. Yeah. Now you are told to evaluate this series. Then you use your hypergeometric function. So, and here is what you are going to do. Now count the numerator, count. So now here's what we are going to do. Now you count the number of uh, of what is having the subscript of n at the numerator and the subscript of n at the denominator. Now check here, 1, 2, 3. We don't know the exact number, so towards tk you can see k. Now the first one will be k, so you have k. K will be at the subscript here. K, you write your f, which is the hypergeometric. Now look at the denominator, 1, 2, 3, 4. You can see here I, be high. So you put the high. Put the high there. Now into brackets. Now at the numerator we have A1. You put comma. We have A2. You put comma. We have A3. You put comma. Dot dot dot. And last one is AK. Then you put your semicolon. You write the next one here. B1, comma, B2, comma, B3, comma, dot dot dot, BI. Then you put your semicolon for the Z here. Then you write the Z. So you close the bracket. So that is the answer to this above series. I'm sure you are getting the logic and the secret behind the hypergeometric series. Okay, now let's do one example so that it will make the lecture to be more interesting. Now, we have sum of n running from 0 to infinity of, let's say, 1 over 2 subscript of n, 1 over 3 subscript of n, 1 over 4 subscript of n, multiplied by 1 over 2 raised to the power of n over, now the denominator, let's say we have 1 over 5 subscript of n, 1 over 6 subscript of n multiplied by n factorial. Okay, now let us evaluate this series. We follow the same procedure. Now let's count our numerator. We have 1, 2, 3. Then you write the 3 there. 3, you put your half. Now count your numerator. You have what? 1, 2. So you put the 2 there. So into bracket, the first term is 1 over 2. The second term is 1 over 3. The third term is 1 over 4. Put semicolon. At the denominator, the first term is 1 over 5. The second term is 1 over 6. Then you put the semicolon. Then the last time here is 1 over 2. You write the 1 over 2, then you close the bracket. So here's the answer to the series above. Though in my next class, I'll teach you guys how you can evaluate this to get a closed form. of the answer. So that will be my next video. In my next video, I will teach you how you evaluate hypergeometric into the closed form. That is the exact form, the exact answer. I get what I'm saying now. Okay, let's look into another series. Yeah, we have something in this form. Here is another series. Number 1, number 2. You have sum of n running from 0 to infinity, positive infinity. Okay, you have gamma of 1 over 3 plus n multiplied by gamma of 1 over 5 plus n multiplied by minus 1 raised to the power of n over, here you have gamma of 1 over 6 plus n multiplied by n factorial. Then you are told to evaluate this series. Now let me quickly recall something for you guys. Okay, now if you have gamma a plus n, it's going to give you a subscript n multiplied by gamma of a from this Pokama symbol. Are you getting what I'm saying? So you can now rewrite it as gamma of a multiplied by a subscript of n. So gamma a plus n gonna give you a subscript n multiplied by gamma of a. So the question is now easy. So then evaluate this one after the other. The first one is gamma 1 over 3 plus n. Then gamma 1 over 3 plus n, it just gives us gamma of 1 over 3 multiplied by 1 over 3 subscript of n. And the next one is gamma 1 over 5 plus n. So gamma 1 over 5 plus n just give us gamma of 1 over 5 multiplied by 1 over 5 subscript of n. Then if we have gamma of 1 over 6 plus n, just give us, so it's gonna give us gamma of 1 over 6 multiplied by 1 over 6 subscript of n. So now I can now rewrite this my series in this form. Then I have sum of n running from 0 to infinity of, now I have gamma 1 over 3 multiplied by 1 over 3 subscript of n multiplied by gamma of 1 over 5 multiplied by 1 over 5 subscript of n multiplied by minus 1 raised to the power of n over, then you have gamma of 1 over 5 gamma of 1 over 6 multiplied by 1 over 6 subscript of n multiplied by n factorial. Then you follow the same procedure as we have did earlier. Then we have something. So before that, let's just bring out these gamma 1 over 3 and gamma 1 over 5 and gamma 1 over 6. Then I have gamma 1 over 3 multiplied by gamma 1 over 5 over gamma 1 over 6 multiplied by sum of n running from 0 to infinity of 1 over 3 subscript of n 1 over 5 subscript of n multiplied by minus 1 raised to the power of n over 1 over 6 subscript of n multiplied by n factorial. Then we have something in this form. We have gamma 1 over 3 multiplied by gamma 1 over 5 over gamma 1 over 6 multiplied by, then we count 1 2, then I have 2f. Now at the denominator I have only 2f1 into bracket 1 over 3 common 1 over 5 semicolon 1 over 6, then they put semicolon minus 1. So here's your answer. So by next class I'm gonna teach you how you can evaluate this kind of hypergeometric function into the closed form in my next video. So I'm sure the video is getting interesting. Okay, now let me do the last example for today. Yeah, the last example for today I have sum of n running from 0 to infinity of gamma a plus n, gamma, say gamma a1 plus n, gamma a2 plus n, gamma a3 plus n, dot dot dot, gamma ak plus n multiplied by z raised to the power of n over gamma b1 plus n, gamma b2 plus n, gamma b3 plus n, dot dot dot, gamma bi plus n multiplied by n factorial. Now, this is very easy. As you all know that is very easy, then this gamma a1 plus n just give us a simple form. That will be gamma a1 multiplied by a1 subscript of n. Very easy. Then that's how you do for others. Then we have sum of n running from 0 to infinity of gamma a1 subscript of n, gamma a2 subscript of n, gamma a3 subscript of n, dot dot dot, you have gamma ak subscript of n multiplied by z raised to the power of n. Everything over gamma b1 subscript of n, gamma b2 subscript of n, gamma b3 subscript of n multiplied by gamma bi subscript of n multiplied by n factorial. Okay, now so you bring out the constants so that the series will be looking very fine and interesting. So you have gamma a1, gamma a2, gamma a3, dot dot, gamma ak, yeah, over gamma b1, gamma b2, gamma b3, dot dot dot, gamma bk. Here you have multiplied by the series n running from 0 to infinity, a1n, a2n, a3n, dot dot, akn, z raised to the power of n, over b1n, b2n, b3n, dot dot dot, bkn multiplied by n factorial. Then we will follow the same procedure as we usually do. Then I have gamma a1, gamma a2, gamma a3, dot dot dot, gamma ak, over gamma b1, gamma b2, gamma b3, dot dot dot, gamma bk. So, and you have 1 2 3 tk, so you got k, f, and the denominator you have I. Okay, sorry, this is I, not k, so you have I at the denominator. Then you have a1, a2, a3, dot dot dot, ak, semicolon, b1, b2, b3, dot dot dot, bk, and then you put a semicolon z. So here is the answer. So this will be the last example for today. So the next class we'll do some integrals that will lead us to the hypergeometric function. Then we solve the integral using the hypergeometric function, and then I teach you how you can find the closed form using your hypergeometric function. So I'm sure you liked the video, you liked the class. Okay, now if you like the lecture, please don't forget to subscribe to my channel. Don't forget to like my videos. Don't forget to comment on the comment section. Okay, now before I go, don't let me forget. Let me quickly give you one exercise to try on your own. Yeah, if you have, let's say you have exercise. So I need the solution in my comment box. So you upload the solution there. Let me check if you guys can do it or not. Okay, sum of n running from 0 to infinity of 1 over 2 subscript of n, 3 over 2 subscript of n, 4 over 2 subscript of n, 1 over 2 raised to the power of n over n plus 1 multiplied by 3 over 5 subscript of n multiplied by 3 raised to the power of n multiplied by n factorial. So I want you guys to try this question. So if you are able to solve this question, let me see the solution in the section box, the answer in the section box. So if you get it right, I'm gonna appreciate you. So please and please, we're gonna meet in our next class. Don't forget to subscribe to my channel, don't forget to share my videos, and then don't forget to like my videos. I like you all. God bless you. Bye.